at Université Laval. I am kind of building on top of David's project a little bit, more of a expansion and specification of drivers of environmental change and cumulative exposure. And my project primarily focuses on the effect of drivers of environmental change on migratory bird populations, specifically migratory bird populations in the Arctic. I'm sharing my screen now. I just want to make sure everyone can see it.
Yes, you're good. You can go full screen.
Okay, perfect. Thank you very much. But yes, so I'm a second-year master's student, and right now I will be presenting the results of my first hypothesis and then building on top of the next steps of my project and going forward to the second hypothesis that I have laid out. And I think I'm slotted to finish sometime around December. But yes, anyway, so the title of my project is the cumulative exposure of Arctic migratory birds to environmental stress. So David has kind of laid the framework for the last 40 minutes about what drivers of environmental change are, but I will briefly summarize what they are in the context of my project, just to give some additional background information. In a particular habitat or ecosystem, a driver is a foreign force resulting in changes to the environment stemming either from anthropogenic or natural causes. The two figures that I have here are from a study that I will be taking the majority of my driver data from. This figure on the right is a cumulative effects assessment conducted from 2003 to 2013 that shows the increase of drivers of environmental change across 21 marine habitats. And the figure on the left here kind of summarizes each stressor as presented on the y-axis against each habitat that was surveyed on the x-axis. So this legend here, cumulative impact, kind of describes the average increase in stress across each ecosystem. And one interesting thing that we should take away from this is that coastal habitats, primarily shown here on the right, such as seagrass habitats, mangroves, salt marshes, are on average exposed to more stress than that of open water or pelagic environments, such as deep hard bottom and deep seamount habitats, where you can see the majority of these habitats are not exposed to a lot of drivers of environmental change, whereas coastal habitats have seen an increase in a lot more. Now, within the context of this study, coastal habitats are very important and they play very important ecological roles. And within the scope of this project, we'll be focusing on how coastal habitats provide key environmental services to migratory birds. And during migration, birds will travel oftentimes thousands of kilometers and need a lot of energy to accomplish this feat. So during their migration, they will stop over at particular staging areas, usually the same areas year after year, in order to eat and regain energy and rest so that they can continue their migratory patterns. This figure here on the right is the migration pattern of the sandhill crane. So the orange areas here on the bottom are where they will stay in the winter. And then when they migrate in spring to breed in the Arctic in the summer, they will stop here around in Quebec City in order to make this journey. And it's kind of imperative that when they are stopping at the staging area, that they are receiving the necessary amount of energy and food and the ability to rest, because this is a great distance that they must undertake. So it's very, very important that these staging areas remain consistent in terms of the resources that they can provide for these birds so that these birds can continue to migrate year after year. And unfortunately, birds are very sensitive to change, and some birds are very unhappy with the way current things are going, like this common sandpiper. So for the focus of this project, we're going with a very large scale, focusing on the entirety of the Eastern American flyway, which basically begins for some birds at the southernmost tip of South America and continues all the way to the Arctic, where many of these birds will breed in the summer. And along the Eastern American flyway, we will be focusing primarily on coastal staging areas and habitats. Now, in terms of bird species that we will be focusing on, obviously there are a lot of birds that breed in the Arctic, but we will mostly be we will only be focusing on waterfowl and shorebird populations. Now, waterfowl and shorebirds are interesting because they both like to use coastal habitats as staging areas during their migration. However, despite the fact that they are commonly found in the same habitats, they have drastically differing population trends. And in a survey conducted in 2019, it was found that since 1970, waterfowl populations have seen a 56% increase, whereas shorebird populations have decreased by 40%, which is obviously a very drastic difference, considering that these habitats or these birds can be found in the same habitats and are using, for the most part, the same geographic resources. And that will bring us to the main objective of my project, which is to investigate the cumulative exposure of staging areas to environmental drivers to explore diverging waterfowl and shorebird population trends. Now, shorebird and waterfowl are very different birds biologically, and we're making a lot of assumptions, mainly residing on the fact that they both use the same staging areas when they migrate, but we'll get into that a bit more later. And my first hypothesis is that drivers of environmental change will have a more significant impact on populations of shorebirds than waterfowl, which is backed up by the differing population trends that we see. Now, to answer these questions, we are using a methodology that was proposed by David in his presentation. In this case, the stress factor is obviously the drivers of environmental change that I've been discussing, and the valued component is the bird distributions. And when we multiply those together, we get a desired effect. Now, for my first hypothesis, we are not focusing on vulnerability quite yet, but I will talk about that in a bit more detail later on. And here is obviously the full figure itself that David presented before, a summation in this case of all of the bird distributions and all of the bird ranges. And here you would have a summation of all of the drivers of environmental change. And here in the bottom right would be the combination of these two figures to get the desired effect, the desired cumulative effect that these birds are experiencing. Now, in terms of data, for bird distributions, we are currently working with BirdLife Data, which is a citizen science organization. So basically, birders will go out in the environment and in a 2 or 3 hour time span, however long they are watching birds, they'll record what species they see and upload it to this website. So it allows for a great comprehensive data set that also spans a very broad range, which allows us to operate on such a large scale from South America to North America to the Arctic. And some of their data is also backed up by tracking data, which helps confirm the legitimacy of this data. And moving forward, we also intend on using data from the Audubon Society as well as eBird, which is another citizen science organization, in order to cross-reference the bird distributions that we're using. And for drivers, we are looking at 2 different studies, terrestrial data from Venter. Here in this data table, you can look at the drivers that we're looking at specifically. And with Halpern that I presented before, we were focusing mainly on marine data. And for our data transformation, we used a simple logarithmic transformation to allow a comparison between these 2 different data sets. And then once we did that, we cropped the drivers to our selected bird ranges in order to use that methodology, that multiplication that I showed before, to get the desired effect. Now, in order to compare different species such as waterfowl and shorebirds, we have to make some important assumptions. And when talking about them on the same level, we want to be able to compare them efficiently. And thus, we're only observing species that breed within the same habitat, which in this case is Belo Island, which is located in Baffin Bay in the high Arctic. Basically, we can assume that they are exposed to the same level of drivers of environmental change while breeding, and therefore any discrepancies in their population trends would be stemming from drivers located at staging areas and along migratory routes where the birds are not all contained together at the same time during the same season. And now to get a bit into the results, me and David built this map that includes the bird ranges of 12 species that we surveyed, 5 shorebirds and 7 waterfowl, as well as the 16 drivers that I presented in the data tables that I just showed you, 8 marine and 8 terrestrial. Highlighted in green is the bird range of one shorebird, the red knot, and highlighted in yellow is the bird range of the snow goose. And when I say bird range, I mean the migratory routes and staging areas of these species. And the star on the top is Belo Island, where they breed in the East summer. Now, looking at these two species specifically, we were able to calculate the average cumulative effect of these 16 drivers on their populations. And now, in terms of this scale, they are quite similar, 4.1 and 4.7, which is kind of expected. Obviously, these birds have such similar ranges that we can kind of anticipate the fact that they are probably exposed to the same drivers. However, leading into the second part of my hypothesis, we are going to take into consideration more the biological aspects of each individual species. So certain species will be positively affected by certain environmental drivers that we are looking at specifically. So for example, snow geese or waterfowl in general, which I'm sure many of you see at parks and like basically any open area that has a small body of water. It doesn't have to be coastal. Anywhere that has like a large area of grass, you can commonly find waterfowl. And these species also benefit highly from croplands and farmlands, which in the first hypothesis of my project, we have assessed as a negative effect on both waterfowl and shorebirds, when in reality, these sorts of drivers, such as farmlands, are most likely benefiting waterfowl populations. So, and then the next leg of my master's project will be incorporating a vulnerability matrix that kind of, on a species-specific level, takes into account the vulnerability and sensitivity of each species to each individual stressor. So, for example, using farmlands as an example, waterfowl would be assigned a +1 value because it's in fact benefiting their populations, whereas shorebirds would be assigned a -1 value because it's actually having a much more negative effect. And when we look at it from that perspective, we'll probably see this number of 4.1 going much higher because the average cumulative effect is actually worse when we consider the biological ramifications of farmlands on red knot populations, and the snow goose average cumulative effect of 4.7 would go down because farmlands are actually greatly influencing their populations in a positive way. So with that in consideration, we'd expect to see a scatter plot similar to this with cumulative effect on the x-axis and population trends on the y. So shorebirds would likely, well, we do know that they have positive demographic trends, and they are likely exposed to lower levels of cumulative effect, whereas shorebirds are likely exposed to higher levels of cumulative effect, but as we know, they have negative population trends. So moving forward, once we discuss with some of the bird experts, including myself on our team, we will be able to incorporate a vulnerability matrix that takes into consideration the biology of each species specifically, as well as their response to each driver that we are looking at. And we also intend to add additional species of shorebird and waterfowl to kind of broaden the scope of this project as well. And just to wrap things up as well, it's important to know, or it's important to take into consideration that birds are excellent biomarkers. They're very easy to observe and they're very sensitive to change. So when things are going poorly in certain environments and habitats, we can look to birds to monitor these effects from an indirect perspective. This project is quite ambitious in terms of its scope, but we hope that its long-range impact will allow us to reach many different areas. Obviously, the connectivity of something as large as the Eastern American flyway kind of emphasizes how many different ecosystems affect each other, even if indirectly. Like, for example, what happens in Brazil still has an effect of what happens in the Arctic, at least in terms of migratory bird population trends. And David already stressed this many times, but the reproducibility of this project is also something that I'm focusing on. And upon my completion of my master's, I intend to upload all of my code to GitHub so that anyone could look through it and even upload their own data to generate results as well. And the last main point that I would like to emphasize is that cumulative effects have never really been used as a means of monitoring bird population trends. And hopefully, if everything goes according to plan, we will be able to use them to predict population trends as well. And that's all. I would really like to thank Catalina for organizing this webinar, David and Phil for helping me out throughout my master's project throughout the last year, as well as Pierre and Louis. I'm not sure if they're here today, but they have been a great help and advising force on my project as well. And that's all I have today, but I would be more than happy to answer any questions if anyone has any.